1,234,104. That's the number of planets orbiting a star other than our own that we've been able to identify so far. And among all these discoveries, we've managed to find worlds with an incredible view, not of just one, but 2 or even 3 suns. And some don't even have any at all. Today, let's take a quick look at exoplanets that, because of their distance from their star and the nature of those stars, are very different from the planets we find in our own system. Let's start with Kepler 9b, an ultra-hot gas giant that had the bad luck of ending up facing a monstrous blue giant. A star that not only is larger and more massive than our Sun, but also has a surface temperature nearly twice as high. For Kepler 9b, the consequences are dire. With an estimated temperature of 4,300 degrees Celsius, this exoplanet turns out to be hotter than the surface of most stars. Partially torn apart by the stellar winds emitted by the blue giant, Kepler 9b is heading toward a very, very big problem. Because its unfortunate companion will soon be gone. It could turn into a supernova at any moment. This dazzling explosion will eject much of its material into the surrounding space, while releasing an amount of energy equivalent to that produced by 100 million suns. More than enough to literally blow away poor Kepler 9b in the process, which in just a few seconds will find itself without its star and with nothing left of itself. There are front row seats where you'd rather not be, but not having a star might be a luxury when you know that we've discovered planets that never had one. Rogue planets. Planets without stars, drifting alone in space. We still don't know if these wandering gas giants were once ejected from their original system, or if they formed, like stars, in the interstellar medium at the heart of a collapsing gas cloud. Although only fewer than 10 such planets have been identified so far, it's believed that there could be billions of them in our galaxy alone. But without the spotlight of stars to reveal them, they are very difficult to detect. They emit their faint radiation from their own internal heat, energy stored during their formation, which still gives them a surface temperature much higher than that of an oven. With their temperature of 450 degrees Celsius, the cloud structures of these giants only shine faintly in the visible spectrum. As you get closer, ordinary human eyes would probably only see a dark disk, barely standing out against the background of the sky. But observing an exoplanet of this type in the infrared spectrum would immediately reveal its internal activity in a completely different way. And while some planets are alone, others have company twice over. Such is the case of Kepler 16b, a gas giant discovered orbiting 2 stars that themselves revolve around each other. If you happen to find an exomoon around this gas giant with a surface to land on, you could then enjoy the strange pleasure of having 2 shadows here in a landscape with 2 suns that set and rise in an atmosphere worthy of the best science fiction movies. And since the 2 solar disks are not the same size, occasionally the smaller star must be eclipsed by its companion. Although they may seem exceptional to us, who have only one sun, binary systems are extremely common in our galaxy, where more than half of the stars live in pairs. And if most planet discoveries are made around single stars, it's partly because their detection is easier there. Of the roughly 4,100 known exoplanets, 136 have been identified orbiting binary systems and 35 orbiting triple systems, such as the Gliese 667 system, where 3 stars coexist in a strange dance. 2 of them, paired together, are close and face each other. They are the center of gravity of the system, and around them orbits a 3rd star, Gliese 667c, which itself is accompanied by 7 planets. One of them, due to its mass and estimated temperature, could very well have the characteristics of a super-Earth in the total desert class. Here it is depicted as extremely hot and inhospitable, with average surface temperatures of over 150 degrees. A world completely dry and scorched, with an atmosphere perhaps bathed in the light of 3 suns. One main sun, scarlet red, and 2 secondary ones, smaller and farther away. A world where nights must be rare. Another member of the procession of these 7 planets could very well claim the title of habitable super-Earth. Because it is possible, given its distance from the star and its size, that Gliese 667cc has favorable conditions to host liquid water on its surface. Within triple systems, several configurations are possible. If, in the system we just looked at, it's two pairs that lead the dance. In the case of HD 131,399, two small stars orbit each other, and this pair itself orbits around another star, alone but much more massive, the central dominant body in the system, where the presence of a gas giant has been detected. From here, in the layers of its upper atmosphere, the variety of sunsets spreading in an endless dance certainly changes throughout the year, depending on the position of the planet in its orbit and the stars in relation to each other. Still within a multiple star system, here is Kepler 13ab, shown here with orange and purplish hues. This ultra-hot giant is 9 times more massive than Jupiter, making it one of the largest hot Jupiter-type exoplanets ever discovered. 10 times closer to its star than Mercury is to our Sun, this planet is tidally locked to its star, which, under the influence of its mass, has forced the planet to always show the same face to it. On one side, it's a real furnace, with temperatures easily exceeding 2,700 degrees Celsius on the side that's always facing the Sun. Yet, Kepler 13ab remains much less hot than it should be, considering how close it is to its star. And to explain this strange atmospheric temperature profile, some researchers assume that the winds keep going, which move here from the side exposed to the Sun to the one plunged in permanent shadow, carry with them an element known to warm the atmosphere of certain planets, like hot Jupiters, and which is also found in our paints and our sunscreens. Titanium oxide, which may fall back into the shadow as flakes. If this exoplanet orbits a star that's hard to miss, there are others that revolve around stars we couldn't even see with our own eyes. You don't know it yet, but you're looking at one of the strangest objects nature has ever created. A star about 10 kilometers in diameter, where matter is so compressed that the volume of a single tablespoon on this star contains as much mass as a supertanker. If it seems like there's nothing to see here, it's because the star in front of you emits most of its energy in the X-ray and radio wave spectrum. But if you were equipped with hypothetical glasses that could perceive this type of radiation, you might be able to see it. PSRB 1257 is a millisecond pulsar, a rapidly rotating neutron star that completes about 1,600 rotations on its axis per second. As strange as it may be, this type of star is relatively common in the universe. But what is perhaps less common is that around this star, slicing through the dark night with X-ray beams as regular as a metronome, planets have been discovered, and they've been given mythical names: Drogra, Poltergeist, Phoebetor, 3 planets that have come back from the dead, as well as the smallest exoplanet discovered to date, with a mass similar to that of the Moon. The presence of this pulsar also tells a story, a terrible story. Here, perhaps millions of years ago, a cataclysmic event took place, the same kind that will one day blow away Kepler 9b. Because for a star of this type to form, a star had to die. So how can we explain the presence of planets here? Are they the remains of ancient gas giants, whose envelopes were blown away by the explosion of the now vanished star? Or maybe these worlds formed later from the material ejected by the explosion of the star and would be, in a way, a second generation of planets born from the ashes of a now vanished system. We just don't know. But to stay in the realm of the strange, let's now go discover an exoplanet that may once have been a star. Here we are again near a pulsar with a mass 1.4 times that of the Sun and spinning at just over 175 revolutions per second. But what makes this rapidly spinning neutron star so strange is that it has a companion only 60,000 kilometers away, 6 times closer to it than the Moon is to us, and which orbits it in just over 2 hours. Although the estimated mass of this object is comparable to that of Jupiter, that doesn't necessarily make it a planet. because it is believed that this strange companion was once a red giant before becoming a small, massive star, a white dwarf, most of whose mass was sucked away, drained by its metronome-like neighbor. So, this pseudoplanet might actually be just a small part of the remains of the core of a vanished star. And to cool things down a bit, let's finish by taking a trip to the coldest exoplanet we've ever discovered. Twice as far from its star as we are from the Sun, this rocky world, 5 times more massive than Earth, is especially notable for orbiting a very faint red dwarf. The average surface temperature here is estimated to be just under minus 120 degrees Celsius. Here, it's so cold that everything, even the atmosphere, if there ever was one, must have ended up solidifying. Think about that the next time you look up at the sky. Around the 3,000 stars that can be seen with the naked eye on a beautiful moonless night, we've been able to identify the presence of about 150 worlds. But that concerns only a tiny fraction of the 200 billion suspected to exist in our own galaxy, which itself is just one among the 2 trillion other galaxies that the observable universe may contain. None of these exoplanets are science fiction. They really do exist. And even though we currently don't have any technology capable of giving us precise images of them, researchers, thanks to the data collected about their size, mass, and distance from the star, are able to model their formation processes, estimate their characteristics, colors, and compositions. Thanks to artists' renderings based on these models, we can immerse ourselves in them. And even if these images surely don't correspond exactly to reality, they have the merit of being plausible and making us dream. Thousands, millions, billions of other worlds taking the form of cold, turbulent, small, pale, calm, giant, angry, and imposing, peaceful, and welcoming planets. And when they have them, caught in the web of their stars, single, in pairs, or locked in a dance of 3. And even if for now we're not ready to set foot there, we can still have fun thinking about it.